Hi, so as you know from previous videos, I've been playing around with this a little and got some encouraging results from it, and I was quite pleased with it until you look around a little bit more. And as you look around on the internet, what you find is there's a whole variety of circuits available for this, and they're very confusing. Some show things in series, some show them in parallel, some show reverse poles, and it's very difficult to work out what actually is going to be the right way to proceed with this. So I made yet another Flynn motor. I think predominantly it's because I like making things. But here's now the test version I've made. Okay, this version, the idea of it is to be able to swap around some of the configurations so that I can actually do a bit more experimentation with it. And if you have a closer look at it, what we've got here are two input coils. So these are the switching coils, and we have the bars of steel running across here and here, and between them we've got some N42 neo magnets. These particular ones are 0.8 centimeters by 3 centimeters, and then there's a couple of 1 centimeter by 0.2 centimeter N42 neo discs to infill the space to make sure that it's the magnets actually touch. So we've got our two switching coils here, and then on here we've got our two output collector coils, again on our laminated steel. Underneath this one here is a tickler coil. So this coil actually has two coils on it. One tickler coil which is wound out of I think it's SWG28 and brought out the back, and then it's SWG34. It's around on all four of these coils. There's about 1,000 turns on each of these coils, incidentally. Okay, so I made this wooden piece, and out through the back there what I've done is inset 10 brass pins. Now the 5 coils comes out through the back, and they're connected to these pins, and these pins have no connection between them at all. And what that's going to allow me to do is make various connections and combinations of the coils there, and to help me to play around with it and try and find out what kind of configuration is going to be the best configuration. Because like I say, if you do a little research on this and you have a look at some of the circuits, the different configurations shown don't necessarily respond to the device itself or compared to each other, and that does make it a bit of a pain. But like I say, mostly I think it's because I like making things, and that's what I've come up with, and I'm quite pleased with that. Actually, as a bit of kit, it'll be a nice thing to muck around with. It's fairly heavy. Right, what I made that out of was one of these. This is a microwave oven transformer. Now, microwave oven transformers are a huge piece of silicon steel laminate, and then they're all got a couple of welds on them. You can see them there. There's the weld line there, and the weld line there and there, that weld these things together. Now, I read somewhere that these are a bit of a bugger to get apart. Actually, they're astonishingly easy to get apart. This bottom plate has 4 spot welds on it, and take a hammer and a blunt chisel to it and give it a jolly good couple of whacks, bend it backwards and forwards, and that bottom plate will drop off, leaving the weld still on there, but leaving actually this whole thing intact, and then take a file to the welds to weld them smooth. If you then saw down this weld line, that weld line there, then the eye is this entire bottom piece is all just eyes. This top piece is E's and this bottom piece is I's. So I started sawing through it, and I actually sawed through it only about that far. Once I did that on both sides, the entire eye section came off as one piece, which I thought was really cool. So I filed down the welds to give me slightly rounded edges, and those eye blocks are then broke up to make the laminated sections that you can see here. So these are made out of an old microwave oven transformer. The eye sections have been broken off. Incidentally, I don't know if you can see that very well. Yes, you can. There is the saw mark that I sawed through the weld on. Okay, so that's what I made the steel cores out of. The bobbins themselves are just made out of a bit of a roofing plastic that I cut to shape, glued together, and then I wound on the wire onto that. This mahogany base here is actually an old door. I sawed it up and give it some finish and give it a nice plane down and sand down to make the base there. There's a reasonable amount of front section here, because if I do play around and find a nice circuit that's going to work on there, I'm probably going to mount that circuit on there so that we get a nice solid sort of Deco Victorian looking piece of kit that's going to do the job that it's supposed to do. The first plan with this, incidentally, is to feed these input pins with a function generator I'll take the function generator from the computer and put that through an amplifier, and then attach the amplifier output to the switching coils, and then I can vary the waveform, and I can vary the time, the frequency of the waveform, take some readings out the output coils, and we can see what we've got. So there we go, there is my experimental version of the Flynn motor. And that's it. Okay, get on with some experimenting now.